Good morning, welcome to new lecture. Today I will review several questions. First question about moment and shear diagram. We have this frame. This is L. This is H. This frame is subjected to uniform distributed load. The intensity of the load is W, for example, kips per feet, L feet, H feet. And this frame is A, B, C, D, E. We want to draw moment diagram and shear diagram for this beam. First step, we should find reactions. In order to find reactions, first I find EY, I have EX, I have AX, I have AY for reactions, because this is pin support. Let's first find EY. In order to find EY, I can write summation of moment respect to support A is equal to 0. From here, EY times L minus W times L over 2 is equal to 0. W, the intensity of the load, times L, the length, it will be the resultant force. Resultant force times the distance up to point we are taking moment will give us a moment. So W times L times the distance from centroid of this rectangular up to point A, which is L over 2, is equal to 0. From here we can find EY will be W L over 2. Summation of forces in vertical direction is equal to 0. From here, AY plus EY minus W times L is equal to 0. Because we have EY, I will plug here, I can find AY. AY from here will be WL over 2. Now I want to find EX. In order to find EX, I can take moment respect to point C for right side only. So summation of moment respect to point C is equal to 0 for right side. In that case, I can write EY times L over 2. EY times L over 2. I'm taking moment respect to hinge C, because here we have internal hinge and we know moment is equal to 0. Minus EX times H minus W times L over 2 times L over 4 is equal to 0. From here, because we have EY, I can plug here. I can find EX. EX will be here equal to W L squared over 4 minus W L squared over 8 all divided by H, so I can write times 1 over H. So I found AY, EY, EX. Summation of forces in horizontal direction is equal to 0. From there I can find, let's see. Okay, let's I simplify this. From here, Ex I can simplify it. Ex will be equal to, that will be WL squared over 8H. So I have Ex, summation of forces in horizontal direction is equal to 0. I'm writing here. So Ax minus Ex is equal to 0. From there I can find Ax. Ax will be equal to Ex if I take the other side, so it will be again W L squared over 8H. So I found all reactions. Now I can draw shear diagram and moment diagram. So let's show the magnitude of these internal, these reactions. WL over 2, WL squared over 8H, WL over 2, WL squared over 8H. Now, shear diagram, moment diagram. Okay, I first will assume dashed line inside of this frame. You can assume in any location, you can assume outside, but always for inside I put dashed line, and I'm assuming I'm rotating clockwise from A to B, B to C, C to D, D to E. Let's see what's happening. Shear force Ax moves in this direction. I will move in this direction. What is the magnitude? W L squared over 8H. Then there is no force. I will continue up. Then shear force always should be perpendicular to the member. So for A, B member, let's see even if I show it another color, I think it is better. Force perpendicular to the AB, it is Ax, will be WL squared over 8H up to here, because there is no other forces. Then load perpendicular to BC and CD, it is AY. So as much as AY, I will move up like this. From left to right, in each step I'm moving from D to C and C to D. There is a load downward. At the middle, how much load we have downward? We have WL over 2 upward, W times L over 2 downward. So at midpoint it will reach to the 0. Then it will go to the negative direction. Then this force will transfer through this beam here, will be perpendicular to the DE. We will move up, we will move from left to right, then we will move down because there is no other force. With Ex from right to left I can close the diagram. Why I put here negative, positive, later on with moment diagram I can explain better. Let's see why that is negative, that is positive. But the magnitude, it is again W L squared over 8h. And here the magnitude, we are moving up, WL over 2, WL over 2. This is shear diagram, moment diagram. Moment at point A, it is equal to 0 because it is hinge. In hinge always, moment is equal to 0. If I apply concentrated moment using 1 rand or something like that, in that case it will be equal to that concentrated moment. But if we don't have any concentrated moment, always in the hinge location, moment diagram should be equal to the 0. So at point A, moment is 0. From A to B, if I move it in this direction and cut just before B here, what is the moment? Moment will be AX times the length h, AX times h. Negative or positive, if you apply moment in this direction, you see that moment create compression in dashed line. So it is negative moment. It will be negative moment. And because there is no force between A and B, the variation will be linear. So here moment negative, and the magnitude of the moment will be AX, which is WL square over 8h times h. It will be WL square over 8. Because this joint B, it is rigid joint. In rigid joint, any moment we have in the column will transfer to the beam, or if we have in the beam, it will transfer to the column. So I can here find moment. So again, in this beam, moment will be negative WL square over 8, because again, if we rotate point B in this direction, counterclockwise, it creates compression in dashed line, so it is negative. At point C should be 0 because it is hinge. From B to C we have distributed load, so the variation should be second order parabolic, so it comes to the 0 and it is curve shape. Okay, it is curve shape. Point C, it is hinge, it will be 0 from WL square over 8, it comes to the 0. The slope from B to C should decrease. Why? Because the slope of moment diagram means derivative of moment will give us shear. From B to C, shear is decreasing, so the slope of this curve should decrease, and you see it is decreasing. Let's see. Again, at D, what is the moment? We can move from E side, that is easier. At E, again, moment is equal to 0 because it is hinge. If I move from E to D just before D, if you cut it, what is the moment? EX times the distance. Distance and load, always they should be perpendicular to each other. EX times distance. Again, it will be WL square over 8, H times H. So it will be negative. Why? Because you see, respect to this point, this load times distance. It rotates like this and it creates compression in dashed line. So it is negative. Negative, again, W L squared over 8. Again, at C should be 0. At D, because it is rigid joint, in other side should be again the same moment, WL square over 8. And from C to D, because we have distributed load, shape should be parabolic shape, something like this. So this will be our moment diagram. Now, if you look at to the movement direction, I'm rotating clockwise from A to B, from B to C, C to D, D to E. Let's see what is happening. From A to B, moment is decreasing. Absolute magnitude is increasing, but if you look at to the sign, negative, for example, 10 is smaller than negative 2, so moment is decreasing. If moment is decreasing, shear should be negative. Negative gets smaller, it means it gets bigger. If moment gets bigger, shear should be positive. Moment gets smaller, shear negative. Moment gets bigger, so it is positive. Once I'm telling about bigger, you can consider the sign. For example, if moment here it is negative 1, here is negative, for example, 20. Which one is bigger? Negative 1 is bigger. Of course, magnitude only if you look at, yes, negative 20 is bigger. But if you consider the sign, negative 1 is bigger. That is the easy way in order to figure out shear diagram sign. It is positive or negative. There are a lot of questions. They ask me why sometimes you show negative inside, sometimes you show negative outside of the frame. There is no difference. Any side you want, you can put contract, you can draw negative outside of the frame. As long as you are putting sign negative, positive, there is no difference. That is your choice. Let's look at the next example. Next example, again it is one frame. Here. Point A, point C, or something like this. Point B, B, A, C. Here I have load 60 kilonewton. Here I have another load 60 kilonewton. So this is reaction, sorry, I put here A, B, C, load 60, 60, the distance 2 meter, 1 meter, 1 meter. Here in this direction 2 meter, 1 meter, 1 meter. We want to find reactions, then draw shear diagram and moment diagram for this frame. Again, let's say show a reaction. Reaction will be AX, AY, BY, for example, BX. Let's find this reaction. First step, I will take moment respect to hinge C for right side. So summation of moment for right side respect to C is equal to 0. That will be BY times 2 BY times 2 plus BX times 4 minus 60 times 1 is equal to 0. I'm taking moment respect to the C for right side of the structure, BY times 2. It wants to rotate right side counterclockwise positive. BX times distance 4 rotates counterclockwise positive. 60 times 1, it wants to rotate respect to the C clockwise negative, is equal to 0. From here I can write BY times 2 minus BX times 4, plus BX times 4 is equal to 60. Now let's take moment respect to point A. If I take moment respect to point A, what I have? I will have By times 4 plus Bx times 2 plus 60 times 1 minus 60 times 1 is equal to 0. I'm taking moment respect to A. By times 4 counterclockwise plus Bx times 2, the distance of Bx up to point A, 2 Bx times 2 plus, let's see, plus, which one is plus, yes, plus 60 times 1, because this 60 times 1, again it wants to rotate this frame counterclockwise positive, 60 times 1 minus, because 60 times this one rotates this frame clockwise is equal to 0. So counterclockwise is positive, clockwise is negative. By times 4, Bx times 2, 60 times 1. All of them counterclockwise. Positive minus 60 times 1 is equal to 0. From here, these two, they will cancel each other, so I can find 2. By is equal to negative Bx. If I plug here, I can find By and Bx. If I plug there, I will find By is equal to negative 10 and Bx will be positive 20. So if I plug instead of Bx negative 2By, or instead of 2By negative Bx, I will find Bx and By. Bx will be 20 kilonewton and By will be negative 10. Negative 10 means I should change the direction of By. I can change it here, so it will be positive. It means 10 in this direction. 10 kilonewton. Now if you write summation of forces in horizontal direction, you can find Ax, and if you write summation of force in vertical direction, you can find Ay. So summation of forces in vertical direction will give us Ay is equal to 70 kilonewton, and summation of forces in horizontal direction, or if you can take moment respect to point C for left side, you can find Ax. Ax will be 40. So Ax will be 40. Now these are reaction. Let's show the moment diagram and shear diagram. This is for shear. This is for moment diagram. Again, I will choose dashed line inside of this frame, like this. And I will rotate clockwise inside of the frame. See what is happening. At point A, what is the force? It is 40. 40, I will move from left to right. Up to this point, there is no force, so I will continue. For this beam, Ay, as much as Ay, I will move up. So I will move up 70, comes here. There is 60 down, I will move down 60. There is no other force. I will move like this. And here with this 10 down, because that 10 transfers through this column and it will be shear force for this beam. So I will close the diagram. Now, this 70 will transfer through this beam here. So if, this 40. This 40 through this beam will transfer here. So here I will have 40. I will move down 60. So there is 20 here. Positive, negative, move down. There is this 20. I will close the diagram. Look at here, always perpendicular force to the member will create shear force. For this member, what is the perpendicular force? This is 40. For this member, what is the perpendicular forces? It is Bx, it is 60. And this 40 through this beam will transfer here. So 40, move down, 60, move down, 20, close the diagram. Or 70, move up, continue, 60 down, there is no force, come here, 10 down, close the diagram. So here this height will be 10. Okay, this is 40. Let's look at the moment diagram. Moment diagram, this was shear V. Moment diagram M. Moment at joint A, it is 0 because it is hinged. If I move from A, B, C, D, E. If I move from A to the D, just before D, if I cut it, what is the moment? It is 40 times the distance, which is 2, and it rotates like this. It creates compression in dashed line, so it is negative. There is no force from A to D, so the variation, it is linear. It will be like this, 40 times 2, it will be negative 80. Because this joint D, it is rigid joint, you will have same 80 for the beam. Then at point C, because it is hinge, should be 0, so it should come to the 0. But let's see how much is just before this load. This just before that load, the moment will be equal to 70 times 1 minus 40 times 2. It will be negative 10. So here will be negative 10, line, like this. One line here, another line like this. That will be moment diagram. Moment at point B is 0 because it is hinged. Just before 60, moment will be Bx times 3, 20 times 3 will be 60. So it will be here positive 60, and because there is no force, the shape should be like one diagonal line. Why positive? Because this Bx times distance 3 just before this load, it apply moment in this direction. That create, if you take with rams and bend like this, it create tension in dashed line. So it is positive moment. What is moment here just before E? It will be 20 times 4 minus 60 times 1. It will be positive 20. So here 20 positive. Because this is rigid joint, here will be positive 20 again. And there is no force, it comes to the 0 at the hinge. In movement direction clockwise, Negative is increasing, means moment is decreasing, negative shear. Negative decreasing, positive increasing, it means positive shear. Positive increasing, moments gets bigger, positive shear. Moments get smaller, negative shear. So our sign is right. Let's look at the next example. Next problem. Okay, it is this way. Ten kilonewton per meter, 6 meter, 3 meter, 3 meter, 5 kilonewton. I want to draw the moment diagram and shear diagram for this frame. Okay, dx, summation of forces in horizontal direction is equal to 0. 5 minus dx is equal to 0. So the dx will be 5 kilonewton in inverse direction. dy, I can take moment respect to point A. dy times 6 minus 5 times 3 minus 10 times 6 times 3 is equal to 0. So again one more time, dy times 6 minus 5 times 3 minus 10 times 6 times 3 is equal to 0. So you can find dy from here. It will be 32.5. Summation of force in vertical direction is equal to 0. Ay plus dy minus 10 times 6 is equal to 0. Ay plus dy minus 10 times 6 is equal to 0. From there you can find Ay. Ay will be 27.5 kilonewton. Okay, let's look at the shear diagram and moment diagram. Shear and moment. Again, I will choose dashed line inside of this frame. So see what is happening in dashed line. And I will move again clockwise. Clockwise, I will move from A to B, B to C, C to D. In order to recognize shear diagram sign. Okay, at point A, what is the shear? Nothing, because there is no force perpendicular to this member from here to here. So it is shear up to there, it is 0. After that you have 5. In direction of 5 you will move and we will continue. Then which load is perpendicular to the BC? 27.5. So I will move up 27.5. From B to C, in each step if I move there is a force downward. It means with constant slope I should decrease that. I will decrease that. It goes to the negative 32.5. With this reaction, I can close the diagram. Here, at D, what I have, let's look at this member, CD. This from A to this point, for example, A, this E point, there is no force, 0. 5, then through this BC beam, 5 will transfer here. I will move 5 from left to right, move down with 5, I will close the diagram, so it will be 5 like this. Okay. Moment diagram. Moment, here it is 0 because it is hinged. From A to E there is no force, so moment diagram is 0 again. Shear is 0, moment is 0. Just before B, if I cut it here, what is the moment? Moment will be 5 times distance 3, it will be 15. If I apply that moment here, it creates compression in the dashed line, it means negative moment. So it will be from here to here, negative 15. Negative 15, because joint B is rigid joint, so that moment from column will transfer to the beam. At beam here, I will have negative 15. From B to C, there is distributed load, so the variation of the moment should be one curve shape, it is parabolic, second order. At point D, moment is 0, because it is hinged. From D to C, if I move, if I cut just before C, what is the moment? 5 times 6, that will be 30. And if you apply that moment, it will be 5 times 6 in this direction. It creates compression. Take with rand, this point, and apply this moment. You see, it will create compression in dashed line. It means negative moment. And there is no force between D and C, so it is linear. The joint C, it is rigid joint, so any moment you have in the column should transfer to the beam. Negative 30, here is 30. Okay. In the middle of the beam, if in the middle, if you take the moment, you will find positive 22.5. Okay. Something like this. Of course, moment here will be maximum in the location of shear is equal to the 0. Where is the shear is equal to 0? Because this is 27, this is 32.5. If I draw by scale, it should be like this. So the shear will not be 0 at the middle because it is not symmetrical. It will be 0 something like here, you can find that. It will reach to the maximum value, there you can find that. And then it comes back here to the negative 15. So exactly in this location, which you can find it at X location, this moment will reach to the maximum. And that X you can find, it is easy. You can cut this frame here and find the shear force and put that shear force, it is equal to 0. It will be 27.5 minus 10 times X is equal to shear here, which is equal to 0. From here, X will be equal to 2.75. So here at 2.75, the moment will be maximum, and you can find the moment over there. How you can find that? You can cut in that point and find moment over there. I'm writing only the equation because it needs calculator. It will be moment over there, m at 2.75 will be equal to 27.5, this reaction, times x, which is 2.75. Okay, it wants to rotate clockwise. If I take the other side, it will be positive. If I write in the moment side, it will be negative. So you see, I put, let's say, write like this: m at x equal to 2.75 minus 27.5 times 2.75 plus 5 times 3 plus 10 times 2.75 times 2.75 divided by 2 is equal to 0. If you take the other side, you will find the maximum moment. And here I'm taking moment with respect to this point, so 10 times 2.75 times 2.75 divided by 2, it will give us the maximum moment magnitude. In movement direction clockwise, you see negative moment is increasing, means moment decrease. Here is negative. Moment increase to the positive value. So here is positive. Moment decrease, negative. Moment increase. Negative decreasing means moment increase. It is positive shear. Let's look at the next example. We have simply supported beam. This simply supported beam subjected to uniform distributed moment, not load, moment. So we have simply supported beam, like this beam, A, B, the length is L. This beam is subjected to uniform distributed moment. The intensity of this uniform distributed moment is lowercase m. For example, m keeps feet per feet, and this is L feet. I want to draw shear diagram and moment diagram. In order to find that, let's find the reaction. If I want to find By, I will take moment with respect to A. What is the By? By times L minus m times L is equal to 0. Pay attention. This is distributed moment, not load. If it was load, for example Q, you should write By times L minus Q times L will be resultant force times L over 2. But here, because it is moment, the resultant moment, you don't need that distance. The moment m times L will give us the resultant moment. Over there it is force. Q times L, it will be resultant force. Force times distance will create moment, so you need to multiply by another L over 2. Here it is moment, so distributed moment, intensity times L, it will give us the resultant moment, so it will be By times L minus m times L is equal to 0. From here, By will be equal to the m. If I write summation of forces in vertical direction is equal to 0, Ay plus By will be equal to the 0 because there is no force in vertical direction. This is moment, not force. So summation of force in vertical direction is equal to 0 means Ay plus By is equal to 0. From there, AY will be negative M. So M downward. This is M upward. Okay, shear diagram. Shear diagram will be, this is downward. M upward, M downward. Because AY plus M is equal to 0, so AY will be negative M. Shear diagram, M you will move down, there is no force. M up, you will close the diagram. This will be shear diagram. How about moment diagram? Moment diagram here will be equal to the 0. The entire moment diagram is equal to 0. Even if you apply distributed moment to one simply supported beam, the deflection of the beam, it will be equal to the 0. That shows internal moment is equal to 0. Why? Let's look at the free body diagram. If I cut here, this is point A, this is M. I apply this M, distributed moment. This is X. I want to find Mx here at X distance. I will take moment respect to cut point, point O. What I have? I will have Mx plus this M times X minus this M, intensity of the moment, times X is equal to 0. These, they will cancel each other. Mx will be equal to 0. So for any x, from x equal to 0 to L, x varies from 0 to L. For any x, internal moment Mx, you see it is equal to 0. Means internal moment will be equal to 0. It means there is no deflection. This beam initially it is a straight line. After you apply uniform distributed moment, it will remain straight line. Okay, I think up to here it is enough for this lecture. Thank you so much for watching this lecture. See you next session. Bye bye.